All right, problem 3 is non-calculator. They love to give problems like problem number 3. I would expect one like this on the AP test that you're going to take. Again, not really sure exactly how it's going to go, but I would anticipate this. We have the integral from -6 to 5 is 7. We're looking for the integral from -6 to -2. Notice our graph. We only have the graph from -2 to 5. There is no -6, but that's okay. When I see something like this, where I have two different values, two different integrals, especially when things match, like the -6's match, that's going to tell me additivity. And so I'm going to look at what I'm trying to find. I'm trying to find the integral from -6 to -2. So I'm going to rewrite that integral using additivity. If you remember the rules for additivity, you can break that integral apart to still start at -6 and then add to that another integral that ends at -2. Now, as far as the other two limits of integration, here and here, as long as they're the same, it doesn't matter what we put there. -7, 3, 158, put anything you want. What are we going to put? That's right, take a look at the problem. We're going to put a 5 there because that's something that we have, and so that would be smart to use. And so I'll put a 5 here and a 5 here. As long as those two match, additivity holds. So we're good. So now it's just working this problem through. I am going to make one tiny little change. We know that we can change the limits of integration and gain a negative sign. So that's what I'm going to do. I'm going to change this 5 and this -2, and that'll change this plus sign into a minus sign. So let me make that change. And poof, like magic, we made the change. The plus turned to minus, and we flip-flop the limits of integration. This way I'm just reading from left to right, which is a little more normal for me. You don't have to make that move, but I decided to go that way. And so, when I work through this now, I'm trying to find the integral from -6 to 2. I have the integral from -6 to 5 first, and I know what that is. It's 7. Done. That's easy. Minus the integral from -2 to 5. When I do the integral from -2 to 5, I have to find a bunch of different areas. I have to find the area from -2 to -1, so that's going to be this triangle here in purple. And then after that, I'm going to have to find the area of this triangle. And then after I find the area of that triangle, I have a third triangle that I can find. And then the last area that I need is this area. That's a kind of a triangular-ish area, but it's not quite a triangle because that's curvy. I'm going to have to, when I do that area, I'm going to have to find the area of the entire rectangle or square that goes from -2 to 5 on the x-axis. I'm going to have to find the gray and the orange area, and then I can subtract off the gray area, and that will leave me with the orange area. That's to be coming soon. So I've got all of these 5 areas to do, and I can do them right here in my area section. So I have 7 minus that first area. That's just the area of a triangle. That's going to be 1/2 the base times the height. So 1/2 1 times 1. And the rest of them are going to work the same way. You're just going to plug all those in. So like magic, we're going to make that happen. And poof, like magic, there it is. So if we look at all of these, I did in different colors for you. The first triangle, 1/2 base times height, 1/2 1 times 1. The second triangle, also 1/2 base times height. Oops, that height I have to change. I accidentally put a -1/2 there. That height should not be a -1/2. That height should be just a -1. So let's change that and correct that to be a -1 instead of a -1/2. There we go. The base is 3/2 because the base starts at -1 and goes to this x value, which is kind of hard to see with it all colored in there. That x value right there, I had to calculate, I had to figure out. The way I figured it out is I looked at the slope of the line. The slope of this line is 2. We can clearly see it goes up 2 and over 1, and so that would have to be 1/2 there, just logically speaking, right? The green triangle, 1/2 base times height. The base is 2 and the height is 3. That should be pretty obvious. And then to get my orange section, I had to do both the orange and the gray. That's the entire rectangle. So the orange numbers that I have down there, 3 times 3, that's the entire square, orange and gray together. And then I'm going to subtract off the gray portion. That gray portion is a quarter of a circle. 1/4 pi times the radius squared, and the radius of that circle is 3. So when I put that all together and do all of the work and combine everything, I end up with 7 minus, and then in the parentheses, I'm going to have 11 minus 9 pi over 4. And then I go ahead and put that all together. I can combine my like terms. I should do that. And I end up with my final answer of -4 plus 9 pi over 4. That's the integral that we're looking for. as far as points are concerned, where you're getting points for this. There's quite a bit of work here, and so this is worth a third of the problem. You get a point for showing some type of additivity. You get a point for showing that you're trying to calculate the areas right or wrong. As long as you've tried to calculate the areas, you'll get that point, and then you get a point for the right answer, as long as you calculate all those areas correctly. So that's 3 points I think we can get. We should definitely at least get 2 of those points. If we make some errors in calculating the area, I can understand that, but we should know the additivity, and we should be able to at least attempt at getting those areas. Next, part B. And like magic, there's part B. We're just simply looking for a straightforward integral. This is not anything too crazy. But we have to make sure that we split this thing apart. If you just do this directly, you will be opening yourself up to making mistakes. I'm going to split this apart into 2 separate integrals. The integral of the 2 times f prime, and then the integral of 4. That's the spot where we would make a mistake. When I write that first integral, I'm going to factor the 2 out of the integral, but I'm going to actually use my right marker. I'm going to factor the 2 out of that integral, so now I have 2 times the integral of f prime of x dx. That's no problem. Integrating that from 3 to 5. And then I'm going to add to that the integral from 3 to 5 of 4 dx. A lot of us are going to forget that that's an integral, and we're just going to add 4, and that's going to be wrong. From here, we can go ahead and do that calculation. We know how to integrate. The integral of f prime, that means find any antiderivative for f prime, and an antiderivative for f prime would be f. And so I'm going to be looking at 2 times f of x, evaluating that from 3 to 5. And then, more importantly, you're not just adding 4 to that. We have to integrate 4, and the integral of 4 dx is 4x, evaluating that from 3 to 5 as well. From here, that's pretty straightforward to do. I'm just going to plug in. We know the fundamental theorem that we can plug in these values. So this is going to be 2 times f of 5 minus 2 times f of 3. And then we're going to add to that 4 times 5, which is 20, minus 4 times 3, which is 12. From here, we just jump to the graph. The graph will give us all of these values. So I can clearly see from the graph that f of 5 is 0, so that's going to be 2 times 0. And then we have minus 2 times f of 3. F of 3, if I just look at the picture, it's tough to see, but I don't need to look at the picture. I'm told what f of 3 is. I'm told right there that the y value at 3 is 3 minus radical 5. And so that's what I'm going to have here, 3 minus radical 5. And then finally, plus 20 minus 12, if I combine those like terms, 20 minus 12 is 8, so plus 8. And then if you put that all together, 2 times 0 is 0, distributing the negative 2, putting it together with the 8, you'll get 2 plus 2 times the square root of 5. Not too bad. Pretty straightforward. Point values here for this part, you get 2. If you know that the integral of f prime is really just f, that's going to be worth a point. And then as long as you get the right answer, that'll be a point as well. So if you only add 4 and not add 20 minus 12, not add 8, that's going to screw up your final answer. But otherwise, we should be able to get those points. That shouldn't be something that's too scary here. Next, part C. Part C is quite a bit of work because it's asking us to find a maximum. And just like magic, there's part C. So we're trying to find the absolute maximum of g of x on the interval from -2 to 5. Notice we have a closed interval. We have endpoints. Those endpoints are automatically going to count as maximums and minimums. We're just going to have to figure out what they are. We also have to see if there are any other maximums and minimums, and we already did this in a previous problem, so finding a maximum shouldn't be that big of a deal. We know that to find a maximum, we need the derivative, and so I'm going to find the derivative of g because that's what I'm trying to maximize. If we look at the function, I have to take the derivative of the integral. That integral starts at a constant, it ends at x. That's just straightforward fundamental theorem of calculus. That hopefully we easily can see that the derivative is just f of x. And so now we have to take that and set it equal to 0 and does not exist. Well, if we look at the graph, and I'm going to get rid of all of those colors from doing the area, if we look at the graph, there are no holes in the graph, there are no breaks, there's no jumps, anything like that. The graph always has a y value, and so it always exists. So I don't have to worry about does not exist. I just simply have to see when this thing equals 0, and hopefully we can clearly see from the picture that the picture touches or crosses the x-axis 3 different times. It touches the x-axis at -1, again at 1/2, and then finally at 5, which is one of our endpoints. From here, we have to determine which of these are maximums and which of these are minimums, so we're going to go ahead and make our chart. our number line chart. Don't forget that you have endpoints, so you have to count the -2. We know that 5 is going to be counted because it's one of our critical values, but we don't want to forget that -2. The rest of them, -1, and then 1/2, and then finally 5. We're interested in what the derivative of g is doing, what g prime is doing, and g prime is f. So we're really looking at what's going on with f in between these values. If we look at the graph from -2 to -1, f is above the x-axis, so that means that it's positive. From -1 to 1/2, it's below the x-axis, and then from 1/2 to 5, it's above the x-axis again. So what that means is my function, my g function, not f we have the graph of, but my g function increases, then it decreases, and then it increases. So that's what my graph is going to look like basically. I don't know exactly, but we don't care. It has that general idea, and so we can clearly see where we have maximums. Hopefully we can clearly see where we have maximums. I have a maximum value here at -1, and I have another maximum at the endpoint of 5. So those are the two maximums. We are tasked to find the absolute maximum. So all I got to do is figure out which y value is bigger. To do that, I can plug into the function for g. So I need to know, or I need to calculate g of -1 and g of +5. So to calculate g of -1, that I'm just going to use the definition of the function, the integral from -2 to -1 of f. I can clearly get that from the picture. We already did that. That's just a triangle, and it's got an area of 1/2. To find g of 5, we did that in part A. That's why I separated that out when I had the parentheses there. If you go back to part A, right here, you can clearly see that we did that from -2 to 5. That's all of this. Be careful. Make sure you're only using that portion. It's not the final answer for part A. It's just that portion, and that portion was 11 minus 9 pi over 4. And so now it's up to us to determine which of those values is bigger. Think of pi as like 3. 11 minus 9 pi over 4 is bigger than 1/2. So the absolute max is that value of 11 minus 9 pi over 4. And your justification can simply be because it's the biggest y value. And that will get you your full credit. How many points do we get for part C? Well, we get 3 points. We get a point for knowing that g prime is the same thing as f, somewhere stating that. You get a point for coming up with these values, and then you get a point for stating what the absolute maximum is with the correct justification, just saying that it's a maximum because it's the biggest y value. All right, and like magic, there's part D. We're looking for this limit. When I first looked at this problem, I instantly thought L'Hopital's rule, because L'Hopital's rule is definitely going to be on the test. But don't let that sway you into doing bad math. I was thinking L'Hopital's rule, but I know the first step in evaluating limit is to just plug it in, and so you need to make sure and do that. If I plug in 1 for x, I get 10 to the first power, which is just 10, minus 3 times f prime of 1, all over f of 1, minus the arctangent of 1. Notice I don't have the limit there anymore. Once you've plugged in, we should know that you don't put the limit there anymore, although we still do. It should not be there. So I just have to evaluate this. Well, let's see. F prime of 1. F prime means the slope of the graph at 1. I can go to the picture and I can see what the slope is at 1. That's the slope of this line right here. And hopefully we can clearly see without too much explanation that slope is 2. And so this becomes 10 minus 3 times 2. All of that is going to be over f of 1. I can clearly see from the picture f of 1 is 1. It passes through the coordinate 1, 1, minus the arctangent of 1. If you just left that as arctan 1, I think they'd give you credit for it, but I would expect you to know the arctangent of 1. That's asking you what angle has a tangent value of 1, and that's pi over 4. 45-degree angle, pi over 4, has a tangent that's equal to 1. From here, you're pretty much done. I'm just going to fix the top. 3 times 2 is 6, and 10 minus 6 is 4. And if you leave your answer as 4 over 1 minus pi over 4, you will have full credit. And full credit for this problem is 1 point. You either get this value or an equivalent value, or you don't. You could get a common denominator for the denominator, make it not a fraction and a fraction, do all that, but there's no point. Again, if you left that the denominator as 1 minus the arctangent of 1, I believe they'd give you full credit. But otherwise, there you go. Problem 3.